Alright, well this was a test of Unit 4 Part 2. And this Unit 4 is all about circles, and Part 2 was all about arcs and chords and how those things are related. We got into arc length and even the segments that are inside a circle or passing through a circle. So this test with its solutions will serve as a good review of circle concepts with arcs and chords and segments. Alright, let's get started. Problem number 1. We're just supposed to solve this for x. Well, x is a radius, so it would be more helpful to draw our radius like this. Okay, since the radius should be the same no matter where we put it in the circle, if it's x here, it'll be x here as well. But putting it here allows us to make this triangle happen. So you've got the 24 is this entire chord. So that means this part of the chord will be 12. So I'll just put a little 12 right there. We have this diameter, I'm calling it a diameter. If I stretch it out, this would be a diameter. It's perpendicular, so it must be a bisector. So I know that that's 12. So of course, now I can do the Pythagorean theorem on this triangle. So we would just say that x squared is equal to 9 squared plus 12 squared. Okay, a little Pythagorean theorem. And then we will go ahead and take the square root of both sides like this. Okay, so that's going to give me x equals. Now, I like to type all of this into my calculator at once. So the square root of 9 squared plus 12 squared. So that's 15. Okay, so x is equal to 15. That's how you do number 1. Alright, take a look at number 2. We learned that if we have a tangent and another tangent that are both coming from the same point, like point A right here, those two tangent segments have to be congruent. So that means that 5x minus 8 has to equal 3x plus 4. So it's just a matter of solving this equation. So I would subtract 3x from both sides, so that'll give me 2x minus 8 equals 4. And then I need to add 8 to both sides. So that's going to give me 2x equals 12. So dividing by 2, we find that x is equal to 6. Alright, so that's number 2. Alright, take a look at number 3. Alright, let's take a look back at some of the formulas that we've worked with over the last couple of weeks. And so we had these 4 formulas that related to angles and arc lengths. Am I going to use one of those? Well, looking at this picture, we're not given any angles, we aren't given any arc lengths, it's all segments. So I will have to look further. Well, so the next thing we got into was the relationship between the parts of the segments in these two situations. So it turns out that if you have a situation like this, where the segments are secant going outside of the circle, okay, that's this situation on the right, then the relationship is that part times whole is equal to part times whole. Now, when I say part times whole, I mean the outer part times the whole thing is equal to the outer part times the whole thing. In this case, that would mean a times a plus b is equal to x times x plus y, like this. So let's see how that applies to number 3. So as I set up to do part times whole is equal to part times whole. So it's going to be like this. the outer part, so I'll do this part first. So 7 is the outer part, and the whole would be x plus 7. Now part times whole with this segment, it's got to be the outer part, which is 3, times the whole. If you do 18 plus 3, that's 21. Now, sometimes kids will want to put 18 plus 3 in here, and then they'll want to distribute that, but I find that to be tedious. So I think it's far better if you have two numbers that you can actually add, just add them. Get your 21, it's cleaner. But of course with the x plus 7, we have an x and a 7. There was nothing we could do with that. Anyway, now it's time to do our distributive property. Bam! Kabam! So that's going to give us 7x plus 49 equals, and 3 times 21 is 63. So there you go. Then we will just subtract 49 from both sides, right? So 7x is equal to 14. Time to divide both sides by 7, like so. And that is going to give us x is equal to 2. All right, that is how you do number 3. Number 4. This is the other situation shown here in the formula sheet. But when the segments are completely inside the circle, what we do is part times part is equal to part times part. So like a times b will equal x times y. So in this situation, it'll be x times 4 is equal to 8 times 10. So this should be pretty simple. X times 4, or 4 times x, is just 4x. 8 times 10, we can just go ahead and put 80. So 4x equals 80. And so just divide both sides by 4. And that is it. Okay, easy peasy. What? Lemon squeezy. So that's going to give us x equals 20. So that is how you do number 4. All right, let's hunt down number 5 and see what's what. Okay, this one again is outside the circle. So we're going to go back to our part times whole equals part times whole paradigm. Now up here is very clear that 10 is the part in this situation, and x plus 10 would be the whole. Okay, so part times whole. So I'm going to do 10 times x plus 10, part times whole. Now over here, you just need to understand that there is only one part. It doesn't go inside the circle. It just is a tangent. So this 20 serves a dual role. It's the part, but in this case it is also the whole. But you have to write it twice. Once because it's the part, and again because it is the whole. So a little distributive property like so tells us we'll have 10x plus 100 is equal to 400. So we will go ahead and subtract 100 from both sides. So that'll give us 10x is equal to 300. And then we will divide by 10 on both sides. Okay, so that is going to give us x equals 30. So there you go for number 5. Number 6. Same scenario as before. No, not the same as number 5. But this is back to this situation. All the segments inside. So part times part equals part times part. So it breaks down like this. This part times this part will equal this part times this part. I'm going to do the red first. So we're doing part times part equals part times part. So 16 times x minus 4 should equal 8 times 10. Alright, distributive property time. So that's going to give me 16x minus 64 equals 80. Then we shall add 64 to both sides. So that's going to give us 16x equals 144. Let's divide by 16 on both sides. So divide by 16, divide by 16. And that's going to give us x equals 9. Alright, that's number 6. Let's find number 7. Okay, number 7. Didn't we just do one like this? It's still going to be part times whole equals part times whole, which is the one we use whenever it's going outside the circle, like this. So I'm going to do this part first. So x is the part, and x plus 6 is the whole. So this will be x times x plus 6. Okay, part times whole. Now again, this 4, because it is a tangent segment, it's the part, the outer part, but it's also everything there is, so it's the whole. So you have to write it twice. Alright, part times whole, 4 times 4. It's the part and the whole. So, distributive property tells us, kabam! So we're going to have, well, x times x is x squared, plus 6x is equal to 16. Now, as soon as I see that I've got x squared and x, I'm thinking probably I'm going to use the quadratic formula. You could also factor if you're good at that. Most of my kids have been struggling with factoring, and especially since we have the TI-30XS multi-view, which can handle complex expressions very easily. It really makes it easy to do the quadratic formula. So we have x squared plus 6x minus 16 equals 0. And it's time to use the quadratic formula. So this is the quadratic formula. Our variables are a, b, and c. And we're just going to substitute. So we just need to know what a, b, and c are so we can do this. So it's pretty straightforward, of course. The coefficients, a, b, and c. Now, c is negative 16. All right, it's that last constant coefficient. B is in front of the x term. That's 6. That just leaves a, which is the 1 that is understood in front of the x. Okay, so a, b, and c are 1, 6, and negative 16. Now, all we need to do is put those in the places where they go. And I'm going to do that directly in the calculator. But you can go ahead and understand that the x is going to equal the opposite of b, so that's negative 6, plus or minus the square root of b squared. Okay, so that's 6 squared minus 4ac. Alright, please do not forget that negative sign. A lot of kids do for some reason. All over 2a. So, but we can type this right into the calculator. Just be careful, we cannot type in plus or minus into the calculator at once. So we'll have to type it in once with a plus and then change that plus to a minus to get the two separate answers. Okay, so here we go. So we hit the fraction button to start off, and we will do -6. Make sure you're hitting this minus key, not this one up here. Whoops. So -6 plus square root b squared. Okay, if you're wondering why I put this in parentheses, I really did not have to put this in parentheses, but sometimes the b value is negative. And if this were -6, it would have to be in parentheses to get the correct answer. So I'm just trying to model for you using parentheses. In case this is ever negative, it will matter. But this time I could have skipped it. So minus 4ac, which is -16. Okay, see, I put in the 1 right here. That's another thing. When you're multiplying by 1, that doesn't change anything. So I could have left out the multiplying by 1 part. But I'm just showing every step. Divided by 2a. And that's another 1 that I could have skipped. So if I hit enter, I get 2. So one of my solutions is x equals 2. I think I'll just put it over here. So x equals 2. Sometimes there are 2 solutions, so I need to go back and check that out. I don't need to type this whole thing in again. If I highlight it and hit enter, I can edit this. So I just need to work my way back to that plus sign, and so I can just change it to a minus sign. Make sure you're using this minus sign, not the white one, and just hit enter. And now I get that the other solution is -8. So as far as solving this equation, the two solutions are 2 or -8. Now, because this is a geometry problem, and this x value represents something, it represents this length right here. You cannot have a negative length, so this solution is what we call extraneous, which means it is not valid. We cannot use it. It is not one of the solutions to the problem in this context. So x equals 2 is the only possible value of x, since you can't have a negative value of x. So just throw that out, do not include it. Alright, so that's number 7. Let's slide on to number 8. We've learned properties that tell us that if the chords are the same, then the intercepted arcs are going to be congruent. So once again, we're just going to set these equal to each other. So that means that 4x plus 18 will equal 3x plus 46. So we'll just subtract 3x from both sides. So that's going to give me x plus 18 is equal to 46. Let's go ahead and subtract 18 from both sides. So that's going to give me x equals 28. So pretty easy. That's how you do number 8. Okay, how about number 9? Oh, new page. Wait, no, I'm missing something. Here it is. Problem number 9 refers back to problem number 8. Find the measure of arc JI and the measure of arc HI. So we're looking for degrees. So let's see what we have here. JI and HI from number 8. Okay, well, arc JI gets its measure from this expression, 3x plus 46. And so let's look at that. So 3x plus 46. The deal is, now we know what x is. So since we know that the measure of JI is equal to 3x plus 46, and we found from the answer to number 8 that x is equal to 28, we can just substitute that in to find the measure of ji. So that should be 3 times 28 plus 46. Therefore, the measure of arc ji turns out to be 130 degrees. Okay, so we've done this part so far. Check. Now we need to find the measure of arc HI. We'll need the picture again for that. Alright, we just found that the measure of arc JI is 130 degrees. Now we're supposed to find the measure of HI, which is down here. But first, let's observe that these two arcs are the same. That's how we solved this problem in the first place. So if this arc is 130 degrees, that means this arc is also 130 degrees. Those are the same. Now the only thing left is this arc down here. And, well, we know that the total circle is always 360 degrees. So all we have to do is subtract from 360. So if we start with 360 degrees and subtract 130 and subtract 130, that's just going to leave 100 degrees. So that means that arc HJ must have a measure of 100 degrees. So that is the answer to the rest of it. Okay, so the measure of arc HI is therefore 100 degrees. Alright, that's number 9. Okay, given that segment DR is perpendicular to segment MB, and MB bisects DR, all that's shown in the picture, what can you conclude about segment MB, and why? Well, this goes back to something that we've talked about in previous lessons, and it's the relationship between these three words: perpendicular, bisector, and diameter. Alright, we learned that these three words are connected because if we are looking at a segment, if any two of these are true, then the third one is also true. So let's see what we've got. Well, we're given that segment MB is perpendicular. Check. We're given that segment MB is a bisector. Okay, it's a perpendicular and it's a bisector. Check. So, what does that leave? Diameter. Okay, so if these two are true, then this third one must also be true. So this is what we can conclude. So it's just a matter of putting this into words. And if I were you, I'd write it up this way. Since segment MB is a perpendicular bisector, we can conclude that it is also a diameter. Notice how I used all three of these words, starting with the two things we were given, and then ending with the thing that we are concluding is true. Alright, so always look out for that. Since it's a perpendicular bisector, we know it is a diameter. Okay, mention all three words. Alrighty, that's number 10. Number 11. Okay, let's just, I think it works best if you sort of mark things on the picture as you go. So, AB is 16. Alright, that means the length of segment AB is 16. So there's that. What else do we have? DE is 16. Okay, so that means this chord is also 16. CD is 10. Where's CD? Alright, here's CD right here. So this is 10. We're supposed to find the length of CF. Okay, we are looking for this guy right here. Let me zoom in on this. Alright, well here's a key piece of business that we have to talk about. First of all, x is not 10. Let's just get that out of the way right now. See how 10 is a radius? Right, because it goes all the way from the center all the way to the edge. Do you see how x is not a radius? It starts from the center, but it does not make it all the way to the edge. So it's definitely not 10, so don't say that. But what we do know is that anytime the chords are the same, so see this AB and the DE, 16 and 16, they're the same. If the chords are the same, then their distances from the center are the same. So in other words, this distance, where the x is, and this distance should be the same. So if this is x up here, then this will be x down here. So it will be convenient to have the x down here so we can do the Pythagorean theorem. So there's x. Since this chord is 16, guess what? This side of the chord will be 8. If this diameter is perpendicular, it must be a bisector. So 16 is 8 and 8. So now we have everything we need. We have the 10, the 8, and the x, all part of a right triangle. All I need to do is the Pythagorean theorem. So that will look like this. X squared plus 8 squared is equal to 10 squared. Make sure your hypotenuse is the number that is by itself. This time it's not the x by itself. Okay, so I could square these if I want to. They're pretty simple. So this would be x squared plus 64 is equal to 100. I could subtract 64 from both sides. So that's going to give me x squared is equal to 36. If I then take the square root of both sides, that is going to give me that x is equal to 6. Okay, so is that what the direction said to find? Well, it said find CF. And CF is x, so we are done. The length is 6. Okay, and that was number 11. Maybe I'll put it up here too. So let's move on and talk about number 12 now. Okay, the measure of arc DE is 32. Arc DE, let's see. So this is 32 over here. What else do we have? The length of segment AD is 40. Okay, so AD is 40. Alright, that's this whole entire thing. Like from here to here is 40. Okay, what else? CE is 10. Okay, so that's this distance. Alright, let me try to stretch this out a little bit. Alright, but this is 10 from here to here. What do you have to say, my darling? You can speak in my video.
Yay.
What do you have to say to America? Mostly my students.
My computer test.
A computer test? What do you mean?
I mean, you know, like what we were trying to do before the birthday party I went to.
Okay, I will help you. Please stand by. I'll be right back, class.
That is silly.
Yes. Let the record reflect that Maya's daddy is very silly. Okay, so I think we have all the information we need. So, we're supposed to find length BF, and that's this radius right here. Since the diameter is 40, then that tells us that any radius will be 20. Okay, like AF, BF, all those would be 20. So BF is going to be 20. EG. All right, EG is half of this chord. So since CE, the whole thing is 10, then that means that EG here is going to be 5. All right, so that's 5. So now we're supposed to find the measure of arc EC. EC. Well, that's this arc right here from E to C. But since this part of the arc is 32, then the whole arc must be 64. All right, just double it. So CE is 64 degrees. Now we're supposed to find the measure of arc EAC. EAC is the major arc that goes the long way around the circle like this. Okay, this is arc EAC that I just drew in purple. Well, that's everything except for the 64. So if we do 360 minus 64, then that should give us EAC. So that should be 296 degrees. So that's it for number 12. Let's take a look at number 13. All right, given that the measure of arc BC is 115 degrees. All right, so we're told that arc BC here, shown now in green, is 115 degrees. And AD is 35 degrees. So that's this over here. So AD is 35 degrees. We're supposed to find the measure of arc AB. But we do know that these two arcs will be the same. So arc AB and arc CD will be the same because of the way they're marked. So all I really need to do is subtract from 360 and divide by 2. So if I subtract 115 and 35 from 360, that leaves 210 degrees. But that 210 degrees needs to be shared equally between these two arcs. So that means we have to take our 210 degrees, divide it by 2, and that's going to give us 105 degrees. So that lets us know that each one of these arcs is 105 degrees, including arc AB. So that's number 13. All right, let's look at number 14. Use the given diagram to solve for x, y, and JC. Okay, let's see. Finding x will be the easy part. It's similar to what we saw in a previous problem. If we look at JM, and then we look at JN, those tangent segments from the same point will always be equal. So we know that x plus 2 has to equal 16. So all we really have to do is subtract 2 from both sides. So that gives us x equals 14. Okay, so that's one answer right there. Okay, x is 14. Let's see, is it time to find y yet? No, it's not time to find y yet. Let's see, what are we supposed to find last? JC. Okay, it's time to find JC next. Okay, JC is this whole length. Okay, this is JC. I'm going to draw here in red. Now, we learned that a tangent and a radius will always be perpendicular at the point of tangency. So we know this is a right triangle. So JC, I'll just put a big old JC right here to be the hypotenuse of this right triangle. Now, if I knew these other two sides, I could simply do the Pythagorean theorem to find JC. But I do know side JM now, because we just found x. So if x is 14, okay, so I could take this and plug it in. So if x is 14, then this is 14 plus 2. So that is 16. Well, I guess that was kind of silly. I didn't need to go through all that. We knew that these two sides were the same, is what it really is. In fact, why am I even looking at that side? Alright, all of that was a little bit silly. I could look at this side over here. This is a right triangle. If this radius is 12, then this radius is 12. So let's just look at this right triangle down here. So doing the Pythagorean theorem will look like this. JC squared is going to equal 16 squared plus 12 squared. So if I want to solve this, I'm just going to take the square root of both sides. So square root, square root. Alright, so that's going to give me JC right away. So I'm just going to put this whole expression in my calculator. So that's 20. So JC is 20, and we have another one of our answers. So let's go ahead and write that down. So JC is 20. Now that just leaves Y. Now hopefully now this is going to seem pretty easy to you, because now that we know that JC is 20, okay, that's this entire length from here to here is 20. If the whole thing is 20, and we know that the radius here is 12, that's 12, this is 12, every radius is 12, then y plus 12 had better add up to be 20. So what does that leave y to be? Y has to be 8. Okay, y must equal 8, because 8 plus 12 will equal 20. Alright, so I guess you could think of, if you need to, you can think of it as doing 20 minus 12 to get that 8. Okay, it's an equal sign. Alright, so y is 8, and that's how you do that. Alright, let's move on to number 15, 16, 17. I guess they all go together. Alright, this will be really easy. We know the relationship between a radius and a diameter, right? Can I see a good picture of one? Yeah, the radius and the diameter, using this picture as an example, this is the radius, and this whole thing is the diameter. So of course the radius is half the diameter, and the diameter is double the radius. So if the radius is 16, the diameter is going to be 32. Just got to double it. If the diameter is 12, the radius must have been 6. I just cut that in half. Now, coming over to the circumference, one formula for circumference is pi times diameter. So if the diameter is 32, the circumference will just be 32 pi. Just put the 30 in for the diameter, it becomes 32 pi. If the diameter is 12, then the circumference will simply be 12 pi. Working sort of backwards, if the circumference is 30 pi, that means the diameter must have been 30, which means the radius, half of 30, must be 15. Alright, so that is how you do 15, 16, and 17. Okay, let's look at number 18. Now, for number 18, we're supposed to find the length of arc AB. As soon as you see that the problem is about arc length, you should be thinking part over whole equals part over whole. This is how we handle these. When we do this part over whole, it's always degrees. Alright, when we do this part over whole, If we're talking about length, then it's always length. Okay. Just getting a little more detail. If we do part over whole, the whole amount of degrees is always 360. So this will always be 360 right here. When we're doing part over whole length, the whole length is something known as the circumference. And we know that the circumference can be found by doing 2 pi r. So just keep that in the back of your mind. 2 pi r will get us this value right here. So let's go ahead and set that up. So when we go to do our part over whole equals part over whole business, the partial degrees is 60 and the total degrees are 360. So the partial length is the length of AB. We don't know it. That's what we're supposed to find. We can just call it x or something. The whole length, as discussed, is the circumference. So off to the side somewhere, we can calculate the circumference to be 2 pi times the radius. The radius is 6. So this is like 2 pi times 6. So that is 12 pi. Okay, so we can take our 12 pi and put it there. That's the part over the whole length. I recommend always reducing this fraction. Working with smaller numbers makes it less likely that you're going to make a careless mistake. So this is going to reduce down to 1/6, and then we have our x over 12 pi. If we cross multiply, we're going to get 6x equals 12 pi. If we divide both sides by 6, that is going to give us x is equal to 2 pi. Okay, 2 pi centimeters. So that is our exact answer. Or if we wanted the decimal, we can just put that in the calculator. Okay, 2 pi is 6.28 centimeters. Alright, so that would be the approximate decimal answer. Alright, so that was number 18. Number 19. You see that we are given arc length right here. Alright, if you are asked for arc length or if you're given arc length, then you should be thinking part over whole equals part over whole, just like we talked about before. Alright, and just like before, this whole is 360, and this whole is the circumference, which is 2 pi r. Okay, so let's set it up. Okay, so part over whole degrees, the partial degrees are 45 degrees out of a total of 360. Now, the partial length, we're given the length this time, the partial length. It's 1.57 feet. That will go here. It is not the whole, it is the part, it goes in the top. Now, we're looking for the radius, but we're not ready for that yet. As discussed, we know the whole length is the circumference. So what we should do first is solve for the circumference, then we can find the radius after that. Let's reduce this first. 45 over 360 reduces to 1/8. So it'll be better if we do 1.57 over c is equal to 1 over 8. If we cross multiply, we see, well, c times 1 is just c. Then we'll do 8 times 1.57. Alright, 8 times 1.57. Okay, I get 12.56. Please don't round this or anything. Just leave all the decimals there. So circumference is equal to 12.56. Now, that's not the final answer. Alright, do not write that down anywhere. We need to continue on to find the radius. And how we find the radius is, since we have the circumference, let's use the circumference formula. Circumference is 2 pi times the radius. Since we now have the circumference, we can take that value and substitute it where it belongs, C. So this becomes 12.56 is equal to 2 pi times the radius. So if I want to find the radius, I will divide both sides by 2 pi. Okay, so if you were asked for an exact value, this right here on the left, this is as close as you can get to an exact value. I mean, it is the exact value, but it doesn't get prettier than that. What we can do is get a decimal approximation, though. So if we put this all in the calculator, okay, that's going to give us 1.9989. Wow. So if I round this even to 2 decimal places, I'm going to have to round this 99 up to 100. Okay, so this is going to become 2.0. Okay, and that is what we were actually supposed to find. The radius is 2.00. Alright, so that's number 19. Let's go on to number 20. Okay, alright, well this is very similar to the last problem in the way that we're going to set it up. We see that we are given this arc length, and as soon as you're given arc length, you should be thinking, part over whole is equal to part over whole. But wait a minute, this time we are not given the degrees. Alright? We normally do partial degrees over whole degrees. Normally there'd be something in here like, 100 degrees or something like that. We're not given the degrees. This number, of course, is not the degrees. It is a length, meters. So we are not given the degrees. So I'm going to introduce a variable for that. I'm going to call it theta. Alright, in higher level math classes, it is traditional to use theta when you're talking about angles. Now, of course, this angle should be the same thing as the measure of arc AB. The measure of an arc is the degrees of the arc. Okay, so if we find this, that'll be our final answer. Of course, when we're doing degrees, the total is always 360. 18.84, that is the partial length of the circle. The whole length of the circle is, this is the circumference. So we need to find that circumference. So off to the side someplace, I'm going to calculate the circumference. Alright, the circumference is 2 pi r. That means the circumference is 2 pi times 9. That means the circumference is 18 pi. So we can take that circumference and put it where it goes. So that's where I'm going to get my 18 pi from. So we just have to cross multiply. We're kind of just stuck with these big numbers. So if we cross multiply, going in this direction, I'm going to have 18 pi, 18 pi theta is equal to, and now I'm about to do 18.84 times 360. But just let me go ahead and write it down. So that'll be 18 pi theta equals, I'm just going to put this in the calculator. I'm getting 6,782.4. Alright, but now I need to divide both sides by 18 pi. Okay, now just be careful about how you type this into the calculator, okay? Alright, but that's all we're going to do. So theta equals, so these will cancel each other out. But, so we're just typing this into the calculator. So we will have 6,782.4. Now, what I like to do is go into fraction mode when I do this. So I'm supposed to be dividing by 18 pi. So in fraction mode, I'm going to do 18 pi like this. Alright, so this is going to be the answer. 119.94. 19.94 degrees. So that is the answer to number 20. Now, just to make a point, if you're not comfortable with the fraction mode, or maybe if your calculator doesn't do it, hopefully your calculator has parentheses. If you do 6782.4, say if you wanted to use this division key, it's important that you do not type in your 18 pi like this. If you do, you will get the wrong answer. See how big this is? It's because your calculator is dividing by 18 and then multiplying by pi because of the order of operations. So don't do that. Instead, what you need to do is put that 18 pi in parentheses. Okay? Now, if your calculator does not have parentheses, then you need to go to the store and get yourself a TI-30 XS Multiview without delay. Amazon.com, about $15. And then you see you will get the correct answer if you do that. Alright, so that was number 20. Let's take a look at number 21. Circumference. We know where that goes. When we do our part over whole equals part over whole, 3 times now we've seen that the whole degrees is 360, but the whole length is the circumference. So this is what we're going to be looking for. That means we better have the partial degrees and the partial length. Let's take a look. When we go to set this up, of course we will have our 360 right here, but the partial degrees, whoops, where'd that come from? 200 degrees. Now, we are looking for the circumference. We don't have the radius, so we cannot just calculate it. But we do have this partial length, the arc length. That partial length will go here, 41.87. So we just want to reduce and cross multiply. Alright, 200 over 360 is 5/9. So this will be 41.87 over c is equal to 5 over 9. So as we cross multiply, we're just going to have 5c equals, whatever 9 times 41.87 is, 376.83. Then we just need to divide by 5. Alright, so divided by 5. Okay, I'm getting 75.366. So it's just a matter of where you're going to round it. Usually I do the nearest hundredth, 2 decimal places, so this would become 0.37. And this is centimeters. Alright, so that is how you do number 21. Alright, number 22. We are given BC is 18. Okay, BC is 18. So let's put that in the picture. We are given that DC is 22. So that's down here. This is 22. let's see, what are we being asked to find? Find the diameter. Okay, that is what we're looking for. So, of course, the diameter is AB, like this. Okay, let's just call that x because that's what we're looking for. So, we've got the 22, the 18, and the x. Now, remember this from problems just like we did before. When it's going outside the circle like this, then we're going to be doing part times whole equals part times whole. So that's what we're going to do. So part times whole, let's see, is there room for this? I'll put it over here. So part times whole, 18 is the part, x plus 18 will be the whole. So we will have 18 times x plus 18, all right, part times whole, is equal to part times whole. Now this 22 is the part and the whole, as we have discussed, so 22 times 22. This deserves some distributive property, so this will give me 18x plus 324 is equal to 484. So let's subtract 324 from both sides. Whoops. Okay, so that's going to give me 18x is equal to 160. Alright, so we just divide both sides by 18. And that's going to give me, okay, I'm getting 8.8 repeating. So that's approximately, I'm looking at my multiple choice answers, and I see they're all one decimal place, so this is approximately 8.9. So there it is, B, 8.9. Okay, that was number 22. Okay, let's take a look at number 23. Okay, what is going on here? So we have that TS is 50. So let's mark these things on the figure. So TS is 50. TS, okay. So that means this entire thing, like this, that whole thing is 50. Good to know. Meanwhile, PS is 40. Okay, PS. So this right here is 40. Alright, now I wonder what we are being asked to find. What is QS? Okay, so QS is the thing that we are being asked to find. So QS is this right here. So this is our target. I will call that X. I'm hoping you can see that this is like several problems that we have done before. It's one of these ones where the segments are going outside of the circle, so it's a part times whole equals part times whole situation. It looks a little funny because of this sort of piece that's sticking out over here, but we really that's not really doing anything. We don't really need it. So there you go. Alright, just forget that was even ever there. Now let's get back down to business. Alright, so this is just a part times whole equals part times whole situation. Now, having said that, be careful. Many students have trouble visualizing the fact that this 50, this segment TS, is the whole. They get so used to doing, you know, x plus something, or they'll even, sometimes I'll see kids do x minus 50 or 50 minus x. None of that is going to be necessary. When we do part times whole, just guess what? The x here is the part, and this 50 is the whole. So when we do part times whole, it's just, in fact, let me just set it up thoroughly. So we're doing part times whole equals part times whole. The part is x. The whole is 50. Okay, so we do not need to do 50 plus x or 50 minus x. The whole is simply 50. 50 is the whole thing. So, and then up here, we've seen this many times. This 40 is the part and the whole, so we will do 40 times 40. Of course, normally we write this as 50x. All right, 40 times 40 is 1,600. Now we just need to divide by 50 on both sides. And see what we get. 32. Alright, so x is 32, so that is the length of QS. Alright, and that is it. Oh, multiple choice. Okay, fine. So that means the answer is D, 32. Kabam. Alright. Alright, so number 24. I better zoom out. Alright, Callie intends to show that these two triangles are congruent. C is the center of the circle. You know, let me put a dot there to emphasize that. And let's see, arc AB is congruent to arc DE. Alright, so fine. These arcs are congruent. Okay, that's all that's given. So, first, segment CB, okay, let me mark that. So segment CB is congruent to segment CD, which is congruent to segment AC, which is congruent to segment CE. Because of what? So why do we know that all these segments are congruent? Well, without even looking down at the answers just yet, we can see that every single one of those segments mentioned are all radii of the circle. And we know that all of the radii in a circle should be the same distance from the center out to the edge. So let's look and see if any of these options say something about all being radii of the same circle. The line segments are all radii of the same circle. Oh, look at that. First one, right out of the gate. So that's it. Answer is A. Next. Number 25. What is the measure of an angle inscribed in a circle if the intercepted arc measures 72 degrees? Well, most of this problem is just testing whether or not you know your vocabulary. Alright, if you know what those words mean, inscribed angle, intercepted arc, that's half the battle. So just in case you have forgotten your vocabulary, allow me to illustrate. Okay, that was a fail. Let me try one more time. Okay. This is an example of an inscribed angle. The inscribed angle was the type with the vertex on the circle. So let's call it theta. This angle theta is the inscribed angle, and this arc that I'm tracing in red is the intercepted arc. So first you just had to have this picture in your head. Now that you're looking at the picture, you need to know the formulas. And this is this situation right here with the inscribed angle, intercepted arc. We learned that the angle is half the arc, or the arc is double the angle, whichever way you want to look at it. Let's see. They told us that the intercepted arc is 72. So they're telling us that this is 72. So if that is 72, then what is this angle? Well, the angle is half. So if I do 72 divided by 2, that should give me this other angle, which is going to be 36. So that's why the answer to this question is B. Alright, and I do believe we are down to our last question of the test. Now, number 26 is also an inscribed angle. Even though it's formed by one of its sides as a tangent, this angle right here is an inscribed angle. Its vertex is on the circle. And as such, as we just discussed, the intercepted arc, which in this case goes like this is the intercepted arc. This arc should be double the angle. So if the angle is 102, that means this arc that I just drew should be 204 degrees. Now we are being asked to find the value of x in this picture. And in this picture, x is what I'm going to show here in purple. Okay, so this is what we are looking for, is the purple. But we know the whole circle is 360, so all we really need to do is take the whole circle, subtract the 204, and that should leave the x part. Okay, so that's why this is going to be 156 degrees. Alright, that's why the answer is C. Alright, that was a long video. 1 hour and 7 minutes. It's kind of a record for me. Hopefully something in that hour and 7 minutes of circle review was useful to you. If so, please show your appreciation by hitting the like button for me. Give me that thumbs up. And I will see you on the next video.